Welcome to my tutorial on programming an AI-based game. Today I'll be showing you how to code basic AI behavior to follow and react to a player. So here's an example of the final project. As shown, the enemies are alerted once they see the player and they'll begin following and attacking. They'll continue to do this until they lose sight of the player, at which point they resume their patrolling status. They'll also fire at the player as a separate attacking function. So to begin, I've set up my scene. I have the player object with a control script. I also have enemies, each of those set up with two patrol nodes called point 1 and point 2. I next have the floor and the terrain baked as a nav mesh for the enemies to navigate. Enemies contain a movement script, which we're going to be editing today, and their nodes are stored in variables. They also have an agent component for using the nav mesh. So we're going to move straight into the scripts. Here we have, I've already set up variables that are required along with some of the functions. This includes firing bullets. The bullet also has a script in which there needs to be a target, which is used to set a direction, and it will basically just move continuously towards that direction. So the first and main part of the code is to set up a state machine. So for this, we'll be using an integer called state. We need to set up a switch statement. So we'll type switch and we'll put our state inside the brackets. For a switch statement, we set up cases labeled by number. So these numbers will correspond to the variable state. So each case has to end with a break. So case 0 and end with a break. For this, so this is just the setup, and we're going to copy and paste this to create a second case, and we'll just label this case 1. And it's always a good idea to comment what the cases are for, so that you remember. So we'll call these patrolling and attacking. Alright, so we'll go straight into the patrolling case. We're going to put the patrol code inside of a function, so we need to call that function called patrolling. So if we go down below, I've already set up the names of the functions. So we're going to start writing the code. So the main functionality for a patrol is for enemies to navigate from point 1 to point 2 and then back again. So I've set up a destination number as an integer, which we will check inside of an if statement. And if the value is 1, then we'll set our destination node, which is simply a vector 3, to be the position of point 1. We'll then use a float called distance and find out how far away the enemy is from this point, so from the destination node. And after we've done this, we just need to check that the enemy has reached that node. So we'll use an if statement to check if the distance has become less than 1 as a float. And if it has, then we're just going to set destination number to be 2. So what we've done is we've checked the value of the number, which is at 1. We then set our point to be 1. If we reach that point, we then change to destination number 2. So we're going to copy and paste this to create the same thing for point 2. So change the number to 2, which corresponds to point 2. And then if we reach it, we go back to point 1. And this basically just creates a bouncing between the 2 points. And this is just a simple patrol. Okay, so this, in order to activate the navigation, we have to use this line of code. We need to set up the agent component for the enemy. In order to use the nav mesh agent, however, we have to set up the AI class at the top. So unity.ai, include that at the top. Alright, so this set destination just takes a vector 3 destination node, and we're just going to continuously navigate towards that. Alright, so the next part is important. We're going to be coding the attacking state. We need a detection range. So what we're going to do is we're going to tell the enemy when to switch between the states. So we're going to use this detection range. First off, we need to set up the distance. So here I'm setting up the distance between us and then the player. And we then use an if statement using our detection range. So if down below here. So we check to see if the distance is less than the detection range. And if it is, then we know that the the player is within range of the enemy, so we can start attacking. So we just, in here, we set a vector 3 called direction, and we also want to set up a raycast hit point. So we'll set up the direction as the player position minus our position. Then we'll set up our raycast point. Right, so the raycast is going to check whether we can actually see the player, whether we can draw a line of sight to the player. So we need to use the physics.raycast. We're going to check if we can see it. And in the physics.raycast, we're going to include our position, the direction that we just set up, and then the raycast hit that we just set up as well. And we're going to draw a line infinitely towards the player. So dot infinity. We next check if the tag that we collide with first is called tag player. So if it is, then we know that we've hit the player. Obviously here we need to ensure that the player object has the tag player set to it in Unity. But if it doesn't hit something called player, then we know that there's an obstacle in the way, such as a wall, so we can't draw a line of sight. Basically what this means is the enemy will only be able to change state if it can actually see the player, so it won't be able to just see them through walls. Right, so simply all we need to do is state that state equals 1. The switch case statement will automatically change, so that's all we need to do. Alongside this, we're also going to do a debug to draw the ray to give a visual representation in our scene so that we can demonstrate how it works. So I'm going to set this as green for if the enemy can draw line of sight to the player, and then we're going to copy this into the else part of the statement and just change this to be red to indicate that we can't see the player. Okay, so of course we need to actually code the attack, for which we're just going to tell the enemy to follow the player. So we're going to just set destination node to be the position of the player continuously. Also, don't forget to call the attacking state up in the case. Okay, so the next thing I have is an alert active function. So this is set up to change the color of from our normal color, which is our standard color, to a new color, which I've decided to be red. And basically down here, we have the call, and we're using a boolean, just a standard boolean called isAlert, and this is going to tell us whether we should change color or not. So we're going to set isAlert to be false for patrolling and to true for attacking. Right, so we'll save that and go back into Unity so we can test it out so far. Make sure that you have your alternate material set up. So I just have a material that's red. And we want to select, so here's my material, we need to select each enemy, and we need to make sure that they have the material set up, and also that the detection range is set up. Mine's at 10 at the moment. You can change this. So if we run the code, we'll see that the enemy is in range to detectors. However, because the ray is going through an obstacle, it's displayed as being red, and they won't attack. In this case, the ray is green because they can see us, and then they can attack, and it changed color. And here, note that because we are not within detection range, we can't draw a line yet, but once we do get within detection range, we'll draw a line and we can attack. So we've seen that the project works so far, and hopefully the color changes help to indicate what's going on. So next we're going to code the AI to pursue the player until the player hides and can't be seen. So we're going to copy and paste 2 more cases for the state machine. We'll label them 2 and 3, and then we'll add comments for firing and pursuit. Okay, so for the pursuit state, we will empty this case out, but we can leave the firing case as it is for now. And then we're going to call detect player inside pursuit. So down below, I again have the function set up. This function will tell our AI to keep navigating towards the last known point of the player until it loses sight. So for this, we set up a distance variable again, looking at how far away the destination node is. Then we need to check to see if we've reached that node, and then if we have, we're going to set the state back to patrolling. So here we set the distance between ourselves and the destination node. And then we need to do an if statement just to check if we're within range of it. And if we are, and we can no longer see sight of the player, we will change back to patrolling. So state equals 0, simply. Right, so now the AI needs to know where the destination node is at. We need to be able to set the destination node to the last known point of the player. So for that, we're going to set the state for pursuit at a certain point. So we're going to change to pursuing at a particular point up here. So we're going to go into the else statement here, and we can simply just call our pursuit here. And this works for the most part. However, I've in previous workings of the project, I found out that it will get stuck sometimes if the player is already in a patrolling state. So all we need to do is check if we are already in a patrolling state and just return if we are. And then in any other event, we can just set the state to 3. So else set to 3. So, okay, so I think that's all for pursuit. It's not necessary to change the isAlert case in this state since it will just stay as it was previous. So we move on to firing. We need to set up some variables. So I have a firing range, which will be similar to detecting. And we have a fire rate timer, which will make sure that the player doesn't just fire bullets every frame. So first of all, we need to set fire rate timer to continuously count down using time.delta time. Okay, so to keep the code optimal, we can reuse the same attacking function for both attacking and firing. So in order to do this, if we go down to the function, we can add a parameter of a type Boolean and just call it something like isFiring. And what we can do, add the firing mechanics to this script. So we'll check to see if isFiring is true. And if it is, then we'll do a second if function, and we'll just see if the fire rate timer has hit 0. And once it does, we can reset the fire rate timer to something like 1 second so that we can see how long between bullets. And then we can just call the fire at target function. So we'll call that, and in the parameters, we're going to put our player, and this will basically mean that the player is the new target for our bullet down here. Okay, so now that we've set the firing up, we need a way to change states from attacking to firing. So for this, we're just going to set the firing distance as something a bit smaller than the standard attacking distance. So in here, where we found if we were hitting the tag of player, we're going to use another if statement to check if the distance is less than or equal to the firing range. So if it is, then we are going to set our state to be 2. And then we can create an else statement here to include our standard attacking state. So all this is saying is that when we're within detection range, we're in state 1, but then if we get even closer and we get within the firing range, we'll switch to state 2. And it will basically be in one of these two. So to finish this off, we need to fill in the bool for this. So for the standard attacking, we can just put false since it doesn't need to be firing, and then for firing, true, and it will start firing. And isAlert can stay true for that as well. Okay, so if we save that, that completes the project. We'll jump back into Unity and just test it out. We just need to make sure, let it load for a second, right? So we just need to make sure that in the enemy, we have set up the bullet prefab and the firing range. I've set mine to 5. And if we hit play, you see that it operates correctly. It includes the firing at the player. And then if we pause, we can still see, oh, 1 second. Give it a minute. If I get close enough to the enemy, then you can still see that there are rays being drawn. So we can turn these off if we want, but I like to keep them on just so that we know what's going on in the background. All right, thanks for watching.